So I want to thank everybody who picked the most complicated topic. I'm now going to try and cover video transport protocols in under a minute. So when we talk about video files, we can be talking about compression, so we can talk about codecs like VP9 or H.264, H.265 or ProRes. We can be talking about wrappers like AVIs and Mpegs. We can be talking about, I don't know, all kinds of things. But today we're going to be talking about transport protocols. So that is the difference between RTMP, RTSP, RTMPS, NDI, NDI HX, SRT, Mpeg DASH, HLS, and some others. So let me take you back. I'm going to need notes for this one. So I'm going to take you back to the mid-90s where Adobe invented a thing called RTMP. And RTMP was a way of moving video from A to B, and it was used predominantly with Flash. It worked really, really well, and it was used for years, and it's still used today. And what you would do is you would send an RTMP, that's real-time messaging protocol video, up to a server, and then bounce that out to millions of people. So it's great. So it could be used on a one-to-one, like a point-to-point, but also it could be used at scale. The problem is that technology now is 30 years old, and Adobe still owns the license. So when you use it, you've got to pay Adobe. People don't like that. And also, it's very heavy on battery usage, and it's not very secure. So a few other companies decided that they were going to try and build something else. So you had companies like Apple who invented HLS. You had Mpeg DASH, you had some others. And these were protocols that were designed to work at scale. So let's say, for example, you want to stream to a gazillion people. The best way to do that, so at the moment, the most common format for that is probably HLS. And what HLS does is it takes chunks, so it chunks up your stream into 30 seconds, or you can set it whatever you want. A lot of people do low latency, so like 5-second chunks. I deliver you 3 chunks, and then what happens is if I lose my internet connection, I've got 15 seconds to catch up, so it gives you a much more resilient stream. So if you're watching Netflix, for example, it's probably an HLS stream. That's why if you cut your internet on Netflix, your stream still works for anywhere between 10, 20, 30 seconds because it's catching up. So that's how HLS works. The problem with HLS is that every time you use it, you've got to pay Apple a fee. So then you get things like Mpeg DASH works similarly. So that's the difference between RTMP. But HLS, because of the way that it works and the way that it buffers, you can't send up to the server. In HLS you can, but it's complicated. So what tends to happen now, we send up to a server on RTMP and then back down in HLS, which is at scale. There are other free transport protocols, things like WebRTC. Now WebRTC is very secure and it works with HTML5. So browsers like Chrome don't need a player to play a WebRTC feed. It can play it within the browser, so that makes it cheap, easy, secure. The problem is, it can't be used at scale, too energy inefficient. So if you're using something like WebEx, that's probably WebRTC, or like a video chat in a web browser, that's probably WebRTC. So then now we've got a situation where the most common transport protocols are things like HLS and Mpeg DASH, but they have 30-second latency. So there's no low latency transport protocol. So then we come up with things like SRT. SRT, secure, reliable transport. So that works in a way similar to RTMP. It's much more efficient, it's much more secure, it's less intensive on your battery, it's lower latency. And that's designed to go over the internet. And it works kind of like TCP, but is a UDP transport protocol. So it checks what it sends. And it uses an algorithm to make sure that you get all the data. So you get a really high quality stream, but at lower latency. Now imagine though, you want to do that on your local networks. This is where NDI comes in. So NDI is great. It's very high quality, very low latency. But the problem with NDI is it's massive bandwidth. Oh, by the way, with things like SRT, I can use any compression algorithm. So I could use an H.264 or I could use VP9, whereas others I can't do that. I'm limited. So now I've got NDI, which is great, but NDI doesn't work over a wide area network. So this is where NDI HX comes in. And this is the newest protocol. NDI HX is probably a direct competitor to SRT. Will it take over? Who knows? And we'll save that for the next installment. Whew.